last minute check, make sure everything's working. Okay, so we're going to go ahead and get started. As I said, this is climate change and the eco-socialist solution. This is a massive pile of information that I'm going to throw out here and hope that some of it you find interesting. And because this is such a complicated topic and we only have 2 hours, I'm going to ask that any questions you have about like what ifs or have you considered this or that kind of thing, if you have those kinds of questions, please email them to me. If you RSVP'd, then you already have my email. If you don't, it's written right there. And then just add the subject 422 climate class and just send them that way. Feel free to, sorry? I'm going to keep this up. Okay. Yeah, so feel free to write down questions that you have. If you have a clarification question, like if I've said something important and I keep repeating it throughout the lesson, and you're just like, I have no idea what you're talking about, what's carbon? Please ask questions like that. I want to make sure that you're getting something out of this. And I understand that this is what I live and breathe all the time, and that's not what everyone else's focus is. So I want to make sure that what I'm saying is comprehensible. So just to go over that again, clarification questions, please do ask. What ifs and have you considered, please email those to me. Just a little bit of background about who I am and why I'm up here and as opposed to someone else. By trade, I'm actually a paleontologist of all things. I'm hanging out here with the skeleton of Deinosuchus, which is a really, really big croc. And I described the first material of this out of our study area in New Mexico. And my source here for all of this stuff, as I said, I've written in specific papers and articles and stuff like that in the notes. But for the most part, my source is my degree. So if you wouldn't mind noticing right there, Bachelor of Science, Ecology and Evolutionary Biology, Geosciences, Earth, Oceans, and Climate. So I have a degree, double major in this stuff specifically. So please just take my word for it, basically. We're going to get into, there's lots of, just pointing out here, this is not something that I got in a weekend. This thing cost me $47,000. So this is worth quite a bit. It's overpriced, but I learned a hell of a lot studying here. And there's a lot of other groups whose information I'm incorporating into this. I will point out that at the University of Arizona, we contribute data to the IPCC. So those big climate reports that you guys hear news stories about, we just had Working Group 3 just put out their new one like a week ago, and then Working Group 2 and 1 were earlier this year. So that data comes from professors who taught me climate science in this particular, in small portions. So
as a presenter to Congress, Jessica.
Right. Yeah, Jessica, she taught me my history of Earth's climate class. So yeah, as I said, these are the major groups that I'm drawing from. Everything else that I don't have specifically listed, just kind of trust me on it. Again, this is why I didn't invite like Turning Point USA, because I don't feel like fighting people on every single little factoid. Yeah, basically, if you don't trust my sources, you're in the wrong place, basically. As I also addressed, I'll be going over common skeptic talking points, not because they hold any credence, but because I want you guys to feel confident in responding to those things if you come across it. And these are the 6 parts that we're going into. First, I'm going to show you the science of climate, physically how things change and what's changing. I'm going to go over kind of how we know the climate is changing in the first place, the historical record of climate change. After that, I'm going to specify what is it that humanity is impacting on these cycles, and then we're going to take a brief intermission. Part 4, we're going to go into climate politics, everything that's happening locally, and then kind of looking at the global scale. On part 5, I'm going to talk about what we should be replacing our current political system with. The answer is eco-socialism, if you didn't get that from the title. And then part 6, I'm going to be going into all kinds of projects that you can do today if you want to start building towards that better future. And so without further ado, we're going to go right into the science of climate. And what better place to start than greenhouse gases? So greenhouse gases is kind of the first place you need to start. And this is a diagram showing how that they work. So greenhouse gases are in the atmosphere. Everyone knows carbon dioxide. Methane is also an important greenhouse gas. And what's happening here is that when these photons are radiated from the sun, they come in a particular wavelength. And then when they bounce off of the surface, they have a different wavelength. And when they come from the sun, they can pass through the greenhouse gas layer. They are transparent to incoming radiation, but translucent to outgoing radiation. So some of this is able to go through that barrier in the atmosphere, but most of it is not. And then it bounces back and basically is pinballing in the Earth's atmosphere. And this is a settled matter of basic atomic chemistry and physics. As I said, we're not inviting denialists and skeptics to this because this is such a fundamental fact that we have established years and years and years ago that if we get caught up in proving like the chemistry of this, we don't get anywhere. There's a lot more to go over. The exact makeup of our atmosphere is fairly variable. Most of it is inert nitrogen. Actually, 78% of what you're breathing doesn't do anything. You breathe it in, you breathe it out, has no impact on you. About a fifth of that is oxygen. About 1% of it is water, and that's what's really variable. About almost 1% of it is actually gaseous argon, and then 0.04% of it is carbon dioxide. And this is our first major denialist talking point, is how can carbon dioxide, which is a small proportion of our atmosphere, have such a massive impact? And the answer to this is a two-parter. So first, CO2 is not the only greenhouse gas. Everything here on the left side is a naturally occurring, and then this stuff over here is the more nasty pollutants that come from our industrial processes. So carbon dioxide, everyone knows that. That's definitely the more common thing we have to keep in mind. Carbon tetrahydride, aka methane, CH4 is really important. Dihydrogen monoxide, water, is itself a greenhouse gas. As well as nitrous oxide, that stuff you get gas with at the dentist, also a greenhouse gas. And then you get into all these nasty things over here that are very, very, very tiny proportions in the atmosphere, but we are responsible for all of this. This is our fault. And secondly, you don't really need a lot of greenhouse gases in the atmosphere in order for it to have an impact. So the small amount of heat that reaches the Earth's surface, the amount of heat that reaches the Earth's surface that comes from greenhouse gases in the atmosphere is 2 times the amount of heat that you receive directly from the sun. I'm going to show you what that means. So this is a big, complicated graph to basically demonstrate you have this amount of radiation that comes directly from the sun, and only 161 watts per meter squared actually makes it. So this is what we receive directly from the sun. Compare that to this pair over here shows back radiation. So this downward column right here is the amount of heat being released from greenhouse gases. And this is the amount of heat being released by the surface. So the amount of heat that we get from the atmosphere, greenhouse gases, is almost twice what we get from the sun directly. Greenhouse gases play an enormous part of the reason why life on Earth is even possible. Right now, the average Earth temperature is about 15 degrees Celsius. Without any greenhouse gases, the average temperature on Earth would be 0. So the average temperature on Earth would be freezing. So we need greenhouse gases. They play a very important part in this. But when you increase their concentration up here, you start getting a little bit too much heat compared to what we're used to. And what makes up the surface is really important here. So sometimes this heat that we receive is absorbed and sometimes it's deflected. Like here you can see 23 watts per meter squared is just directly reflected by the Earth. This is sunshine that the Earth rejects, basically. And what material the surface is made out of plays an important part there. So albedo is our term that ranges from 0 to 1. 0 albedo means you're a perfect black body. You're just a perfect black sphere that absorbs all radiation that comes to you. And then a 1 has full albedo, you don't absorb anything. And everything else is in between those two values. So liquid water, this is an important thing to keep in mind. Liquid water has an albedo of 0.05 to 0.15. So it's absorbing almost all of the radiation that it receives. However, solid water in the form of ice has an albedo of 0.7 to 0.9. So almost all of the energy that hits a sheet of ice is bouncing back into the atmosphere. Think about the difference a car's color makes when you park it outside in the desert heat for a couple of hours. So I drive a white vehicle because I was born here and I'm not stupid, but you get, people who come into Arizona in their big black SUVs and they park it, not in the shade in Target for 2 hours and they come back and it's an oven in there. And that's because the color of the paint is affecting how much radiation that car is absorbing. So you can even demonstrate that with, material. To wear a different colored shirt and stand in the sun, and you'll notice the difference. Yeah, as I said, albedo is really important when it comes to the melting of ice sheets and the formation of ice sheets. So you can see here these dark colored areas that aren't penguins. This is rock. And as ice melts, you have this exposure of a low albedo surface. So this rock is absorbing more heat, and that's causing the melting of nearby ice, which then exposes more rock, absorbs more heat, melts more ice. That process works in reverse as well, where if this surface is then covered in ice, you're going to have a regional cooling effect and more ice will form. So basically, you have a positive feedback loop in both directions. In this case, we really don't want more rock to be exposed because that's pushing us in the wrong direction. Water plays an important part in absorbing energy. If you know anything about nuclear energy, you know that we've got those giant towers of water that are there to absorb radiation. It's because they're really, really good at it. The bonds between hydrogen and oxygen and water are super duper strong. So they can absorb a lot of radiation without turning into steam, basically. So 71% of the Earth's surface is covered in water. 90% of the solar radiation that makes it to the surface is absorbed by just the upper 10 meters of the ocean. 90% of what we receive, that 161 watts per meter squared, is absorbed by just the upper, say, 30 feet of the ocean. And the total amount of energy stored in the atmosphere is equal to the amount of energy stored in just the upper 4 meters of the ocean. So you think about how much energy I was showing you is stored here in the atmosphere. It's child's play compared to what's in just the surface of the ocean. So water plays a really important role in this. Popular denialist talking point, more CO2 in the atmosphere is good because plants use carbon dioxide. So when you put out carbon dioxide, more plants will grow. This is a childish misunderstanding of how the carbon cycle works. Not to get too deep into it, basically there's the drawdown portion and then there's the emission portion. And this drawdown section over here is determined by, so this equation down here is very, very important. And in this drawdown section, this equation is moving forward. So when you combine carbon dioxide with water, you turn that into this molecule, which is sugar, and you create oxygen. So this is photosynthesis. This is photosynthesis right there, that part of the equation. When you take oxygen and you react it to sugar, either by metabolic combustion or by literally setting it on fire, this is ignition happening in the other direction, you release water vapor and carbon dioxide. So that's this portion of the equation. So basically, our whole issue is just this chain moving back and forth and back and forth and back and forth. But there is a way that carbon is removed from the cycle. So sequestration is the process of taking atmospheric carbon and then putting it in a form where it's no longer a part of the cycle. So you put it down, physically bury it into the earth. And marine plankton and other kinds of small organisms play a very key role in this. But basically, and actually mountain erosion as well. But basically, carbon is taken from the atmosphere and then flushed out and physically buried and removed. That's going to be an important thing to keep in mind later, because this is what we need to be doing on a planetary scale very, very quickly. You might not know this, but shelled animals like seashells and stuff, these also play an important role in that sequestration process. So these are seashells I found on a beach, and these are fossilized mussels that are about, I think they said about 15 million years old, that are in rocks also on a beach I found in California. These couldn't have been more than maybe 50 miles apart. But essentially, the fossilization of these seashells is a big part of removing carbon from the cycle. Basically, these animals marry carbon with calcium, turn it into calcium carbonate, which is seashells, and then it removes it from the process. There's also a lot of where you get really messy with denialist claims where they say that, well, scientists just aren't taking into account the fact that the Earth can be farther away from the sun. Sometimes the tilt is different. They're not accounting for this. And so what we're experiencing is just a natural cycle. The planet warms sometimes, it cools other times, we're fine. Yeah, so we actually do know these cycles very, very well, and we have accounted for their impacts on the climate. So the first thing that they might bring up is eccentricity. These are called Milankovitch cycles. So eccentricity is the shape of the Earth's rotation. It doesn't change quite this much. This is a dramatization just to show you. But basically, yes, sometimes the Earth's orbit puts it further away from the sun than at other times. This is accounted for. We know about this phenomenon. This happens on about 10,000 year cycles, or sorry, 100,000 year cycles. So every 100,000 years, we go through one of these. The change in obliquity is also important. These happen on 41,000 year cycles, and that's basically the change in the tilt of the Earth's axis. And when the North Pole is a little bit further down, that has higher seasonal variability in our temperatures. And when it's closer to fully erect, you have less variability. And again, we know about this. This happens in every 41,000 years. The final thing is precession. Precession is just a nightmare, weird. It's such a funny thing. And we don't actually have a solid, this is actually still debated as to how much precession impacts the climate, but this happens on about a 26,000 year wobble, this wobble happening right here. This happens far more often than either of these two. So we know about all these different changes that the Earth physically goes through, and it's in our models. And so this is an example of a model produced by the IPCC. And so when you simulate for all of those natural phenomenon, just solar and volcanic emissions, basically, this is what the Earth's temperature should be. And this is what it actually is. So we know that, and just to establish this early, the 0 degrees difference, this is the pre-industrial average. I'm going to be referring to that a lot. So this is basically what the temperatures were at about the year 1800. Some people put it 1850. And then here we are today at a little over 1 degree Celsius above that pre-industrial average. So this is the change that we've experienced just in the last couple hundred years. Questions on part one? Anything on any of that we want to go over? All good?
Anything about, some gases, greenhouse gases dissipate more quickly than others.
Yeah.
Just about the physics of the limiting nature of trying to get rid of carbon dioxide.
Yeah, so carbon has a pretty long, I'm forgetting the word that they use, but basically life cycle in the atmosphere. CO2 stays up in the atmosphere for quite a long time. Some of these other man-made compounds that I was showing you, they do tend to, say, precipitate out fairly quickly. So that does play a role, yeah. And those numbers are fairly easy to retrieve if you're interested in pursuing that. Any other questions? Okay, so we're going to get into, this is my favorite part, historical climate changes. Again, denialists love to bring up the fact that the climate has always changed, it will always change. It's childish to be freaking out about the fact that it's changing now. And I like to point out that yes, the climate has always changed. And the reason why we know that what we're doing to the planet right now is dangerous is because the Earth has changed in ways that are similar to what we're experiencing now. This has happened previously. I'm going to show you examples of what has happened before, just to give you an idea of the fact that we do know what the impact of this will be because it has happened. And people who study the fossil record give that information to us. So several periods of Earth's history are marked by rapid, it's usually changing climate, changing chemical cycles, that leads to a mass extinction. And we define a mass extinction as where at least 75% of living species go extinct in a geologically small period of time. So that's not like 50 years, it's usually a couple of million. And when we talk about the 6th great extinction that we're currently going through, keep in mind that we're in the very early stages of this, and that if this truly does become a mass extinction, it's going to get a whole lot worse than that. We're nowhere near the 75% value. Yeah. So yeah, we're going to be examining just a couple of these things. There's 2 specific mass extinctions that I want to show you, and then an additional example of the climate cooling or changing in a different direction, in a cooling direction. This is unrelated. I just wanted to flex the fact that I've been up close and personal with a baby raptor. So, and to give you guys a little bit of a time scale, just to show you how much time has moved, I'm going to put this down at the bottom of these slides. On our old scale caliber, I've marked it with the Cambrian extinction. So this is the beginning of the time period that we care about is when most groups of modern animals start showing up. Everyone's heard of Anomalocaris, and basically if you look up memes on the internet of like fossil things, you'll get these like brightly colored, super like fragged JPEGs of horrible little creatures living at the bottom of the ocean. That's the Cambrian. And then on the other side, I've marked another global phenomenon that people should be familiar with. This is, you can find records of both of these things traced into the earth. So this is our beginning. That's the Cambrian extinction, or sorry, the Cambrian explosion. And then moving forward just a little bit of time, the Silurian, we start having the first organisms living on land. So Cooksonia is this really, really tiny little plant that is one of the first organisms that's able to move onto the land. And then from here in the Silurian, just a little bit further into the Devonian, you start getting the innovation of trees. So a tree is something that, it's not its own botanical category. It's actually, it describes the structure. And so trees as a long, tall plant, that was not invented, quote unquote, until well into Earth's history. And the reason they were able to do that is because they developed, I should probably flip these slides around. It developed a compound called cellulose. So cellulose in the trunks of these trees is what allows tiny little Cooksonia to grow into this 8-meter long tree log, basically. And as these trees are growing up tall, they're putting down deep roots, and they're doing chemical erosion of the rock. So they're releasing compounds that are eroding the rock and breaking it down into minerals and other kinds of nutrients that can be used. And so basically these trees are breaking down rock, releasing nutrients, and those nutrients are being washed out into the sea. Cellulose, because it is a new compound, it's a new strong type of natural compound. This is not something that anyone could decompose for a really long time. So trees grow their own thing, and all the, the detritivores, the things that break stuff down, they're like, I don't know what the hell to do with this. So trees essentially just kind of laid around on the landscape for, we're not entirely sure, but hundreds of thousands to millions of years is how long it took for an organism to be able to eat and break down cellulose. And so because of that, trees are building their structures with atmospheric carbon. They're dying and they're being buried, but they're not being broken down. So that carbon is not then being released back up into the atmosphere. So this is sequestration. And this happened on a massive scale back in the Devonian. And we're going to get into the impacts of that in a second. But in regards to the Devonian Pennsylvanian extinction about 372 million years ago, that was caused by all those nutrients being flushed out into nearshore environments, causing algal blooms. So just like today, where if you are kind of irresponsible with your agriculture and you're putting manure and fertilizers on your land, and then that's getting washed out into rivers or oceans or stuff like that, you cause algal blooms. Algae say, here's a bunch of free nutrients, I'm going to use them all up, I'm going to build these giant algal mats everywhere. And algae is kind of a hog, so it takes up all of the oxygen in the water, and that kills off everything that's not algae. And so essentially, this is back in a period of Earth's history where most things are just pond scum living in shallow water. And when you pollute basically every nearshore body of water across the planet, you're going to kill off almost everything. And that's exactly what happened about 372 million years ago. But we're not done, because all that carbon that was stored underground from those buried trees, unfortunately, at about 252 million years ago, a massive bout of volcanic activity in Siberia starts pushing magma up through those carbon stores, and it starts burning all that coal. And this was the closest life itself has ever gotten to just not being a thing anymore. 96% of marine species and 70% of terrestrial species go extinct in this period of time. So what happened? Well, carbon in the atmosphere causes global warming. So first of all, just we know that putting carbon in the atmosphere causes warming because we can see it in the fossil record, it kills everything. In addition to that, carbon in the atmosphere means that the oceans are now taking up that CO2, and that lowers the pH of the ocean. So essentially the oceans become more acidic, and shelled organisms like our friends, the bivalves, they don't tolerate that very well. So a lot of those organisms go extinct as well. So this is just generally a really bad situation. Thankfully, it's not quite this bad yet, but this is kind of what we want to avoid. We don't want to end up doing a Permian Triassic extinction to ourselves. Another example I'm going to point to you, just as far as how living things can historically impact the climate, is this tiny little plant called azolla. So azolla is a freshwater fern. It's really, really tiny, and it floats on the surface of water. And it has a remarkable ability to fix carbon and nitrogen. So unlike most other plants, it doesn't have roots. And so the nitrogen and the carbon it's taking in all come from the atmosphere, as opposed to from the soil. And in doing so, they build their bodies. 1 acre of azolla, this was determined experimentally, 1 acre of this plant can draw down 6 tons of carbon and 1 ton of nitrogen per year. And these things also double their mass in under a week. So they grow quickly, they sequester a ton of carbon. And then in one particular instance, about 48.5 million years ago during the Eocene, this is after the dinosaurs die. Dinosaurs all die out right about there. And I don't bring that extinction up at all because that's like the only example of a mass extinction that was nobody's fault. It was just an asteroid came in out of nowhere and it killed almost everything. That's not on anybody. That's just an accident. But during the Eocene, about 48.5 million years ago, up here in the North Pole, this is what the continents would have looked like at that point. Europe is still kind of forming. We used to be an island for a really long time. And you have this ocean basically trapped up here at the North Pole. And fresh water is washing out and forming a layer on the surface. And so there's all this fresh water, there's all these nutrients. And this azolla, these are azolla fossils, but this is an organism that's still around today. Basically, azolla grew this gigantic pond here at the top of the world. And as it's drawing down carbon, building up the plants, and then as the plants die, they sink to the bottom of that ocean. And again, it's anoxic. So there's no oxygen down there, and it means that there isn't anything to break it down. So all of these plants are dying, getting buried, and that carbon is now removed from the cycle. And so during the Eocene, atmospheric carbon drops from 3,500 parts per million to 650. And it seems to be, this is really what was doing it. There aren't a lot of other examples. Basically, it could be this, or it could be a mountain building event. And around this time is kind of when the Himalayas start uplifting, but they haven't really gotten going yet. So scientists are pretty sure that it's this azolla bloom in the Arctic that was responsible for cooling the planet. And basically the reason why there are no tropical forests in the poles anymore is because this plant was far too successful and basically destroyed its own ecosystem. Any questions on that stuff? Anything at all? Okay, then we will get into part 3, the extent of human impact. So where it gets a little grim, I'm sorry. So as I've discussed previously, we've got all these complicated systems that govern how the planet regulates itself. And human beings coming on the scene, we're innovating materials and we're doing things to the environment that it has no natural defense against. And so we're going to go into specifically what we have done to change these things. And so just to get this out of the way, the climate is warming. We know this for certain. So this is carbon dioxide concentrations from 800,000 years ago to about today. And yeah, right around here is where that pre-industrial average starts as far as temperature. So this whole part of the graph right there, that's our fault. All this other stuff over here, these are, again, those Milankovitch cycles and stuff like that. This is not accounted for. This is the cause of, or this is caused by humans burning carbon. You burn carbon, it goes in the atmosphere. We can see it on a graph. I don't know why that's so hard for certain people to understand. I just don't get it. And in addition to that, we know that there's a link between that carbon and the warming of the climate. So again, here's that pre-industrial average as far as temperature goes. And here's where we are today, doing about 1 degree Celsius warmer than was normal just a couple of 100 years ago. And again, this is all generated data. We know this for certain. So it's a common talking point, and this is actually more or less a direct quote from Ted Cruz. They say it used to be called global warming, but then they, whatever that means, changed it to climate change because they discovered the climate wasn't warming. So this is the idea that because the terminology is slightly different than it was 15 years ago, that it's because we're backing down on the concept of global warming. We know that it's not warming. The globe is warming. However, it's not warming the same amount everywhere. And there's a lot more things happening than just warming. So if you can't see the timer down there, it starts at 1880 and goes through, I think, 2015 or 2016. And these are temperature anomalies. So a perfect white space is just the pre-industrial average. Blue is temperatures that are a little bit cooler, and red are temperatures that are anomalously warmer. And as we go through over just the last couple hundred years, you can see that, yeah, at the beginning, it's kind of here or there, it's a little bit spotty. Some places are being more affected than most. But as we start getting into my lifetime, you can tell it's getting hotter. You can see that those heat anomalies are getting worse, and they're more universally distributed. Look at what's going on over here in Antarctica. I'm gonna let this go through one more loop. Check out how much hotter it's getting just over here. Look at that. So that's not great. And in addition to that, as I said, as carbon in the atmosphere is interacting with seawater, the chemistry of the oceans are changing. And so this is just a little sea critter. They build their shells out of calcium carbonate, just like everything else. And as the pH of the ocean drops, as it becomes more acidic, these organisms start having their shells dissolve. And that obviously that impacts their biodiversity. It also impacts their part of the carbon drawdown cycle. So as the oceans acidify too much, we lose the ability to sequester carbon through this natural process. I also want to point out an important thing when it comes to trophic dynamics. This is a really important thing that is not well taught, is the idea that you only get about 10% of the energy that's available in the food that you eat. So if there's so many calories in a hamburger and I eat that, I'm only getting 10% of the available chemical energy in that. And that happens every time you make a jump up the ecological scale. So you have 100% of the food at the plant scale, the autotrophs. Only 10% of it is transferred to the herbivores. So 90% of that energy is lost in that jump. 90% of it is lost again from herbivores to primary predators, and then another 90% is lost from here to here. So the secondary predators are getting a fraction of the percentage of available nutrients and energy that is available down here. So I want you to think about, when it comes to our personal choices, how inefficient it is to feed a planet of billions of omnivores. We actually have the option of eating plant-based meals and stuff like that and getting more, getting more energy from this part of the cycle as opposed to up here and up here. We have the choice to basically not lose that much energy. And particularly in a meat-heavy diet, we are feeding our food, and we're losing 90% of that energy in that process. So this is an important thing to keep in mind. And clearing space for agriculture means that most of the time, what's being planted in place of like natural prairies, here I'm talking about like the Midwest, right? You have these great plains that are then cleared out and replaced with just corn. So you're losing the plant community, you're losing the insect community, and crop monoculture is a leading driver in biodiversity loss. So this idea that when we want to grow food, we're going to clear everything and just grow that is not a good idea. We need to stop that really, really quickly. The plains, since I brought it up, those also play an important role in carbon sequestration. So this scale over here, these 1 meter, 2 meters, so down here, this is about 3 meters deep. And on the left side, you have the basically our food crop. This is our annual wheat. And on the right side, these are the plants that were dug up in order to plant our wheat fields. This is perennial grass. So you can see that even at its best, the annual wheat puts down a tiny little thing of roots. And of course, this is all ripped out at the end of the season. But perennial grasses put down this massive load of roots. And this whole thing is carbon. This whole thing is sequestering carbon. So again, when we have these big fields of one plant that's all being planted and then ripped out at the end of the season, we're not doing carbon storage in those areas. So that's an important impact we need to consider. Deforestation is obviously really crucial. 12% of our total emissions come from deforestation. So when you cut a tree or you till the land or stuff like that, you are killing plants and releasing CO2. So 12% of our total emissions come from that process alone. And in this case, urban sprawl, especially in Phoenix, is a big problem here. These areas are no longer biologically active, partly because we've paved them and are living on top of it, and partly because, culturally we are not, and when I say we, I mean white Americans are not good stewards of the land, and we're not taking care of this land the way that it should be. And we're going to get into that more later, but so that's the end of part 3. Any questions on any of that? Question?
Yeah, when you talk about the bioavailability of nutrients between these different trophic levels, what is the cause of that? Is it because, for example, if I kill a chicken, and I only eat the major cuts of meat and I throw the rest out, is it by that route or is it by my digestion?
No, that's an important point as well, just as far as general food, just food waste in general. It's not from how efficient you are at eating it. It is just general inefficiency in our digestion. And that just kind of across the board ecologically, the best an organism can do is about 10% of available energy. Some are better at it, some are worse. So actually, yeah, if you consider the fact that we're not eating the entire part of the animal, we're getting less than 10%. But yeah, that's an important question. Yeah. Anyone else had things I wanted to point out? We're doing really well on time. So if you have a question, please let me know. Anything? Question?
So it's a comment.
Yeah.
Question. I don't know if that's out of line.
We got time.
Okay. Yeah, I'm just reading a book by Chad Hansen called Smokescreen,
Okay.
which talks about the U.S. Forest Service and the logging industry's collusion in destroying forests under the guise of post-fire salvage logging.
Yep. Yeah.
And one of his big themes in the book is exactly the contribution that preserving forests and, in fact, increasing the area that forested would make. Yeah. At least slowing down climate change.
Yeah.
This is kind of getting into the institutional stuff that I think we're going to talk
Yeah.
about later.
Yeah, but that is an important part to bring up. And in fact, I should add those to the ends of these slides, is that here, especially in Arizona, we've got all these wonderful ponderosa forests up north. And because of the way that we treat land as this permanent thing that has to be kept perfect at all times, and not allowing the natural fire regimen to do its own thing. First of all, we make fires way worse than they would be normally because we're just building up tinder and allowing stuff to dry. But yeah, there's many different types of plants, including the ponderosa, for whom fire is an essential part of their ecology. There's a lot of plants that will only, their pods will only open when they've been exposed to heat. And that's because just through the process of evolution, the most successful members of that species are ones that hatch, for lack of a better term, when they start germinating right after a fire comes through. Because fire breaks down organic material into bioavailable carbon, and ash is actually a really good fertilizer. So, the fire ecology of the West, that's actually a whole part of this that I really should have gone into, that I'll definitely have to add later. But yeah, that's a really good point. Is that specifically, yeah, the way that we choose to manage forest here is particularly inefficient. Okay, so if you guys don't have any other questions, we're going to go to intermission. This is a class taught by someone who hates being a student, which is why I do things a little bit strange. But okay, so we're going to get into climate politics, local to global. You thought I was done with the paleontology and you were incorrect. So something I want to demonstrate is that where we live has always been a corridor for migration. So about 3 million years ago, this little area right there called the Isthmus of Panama closes. And so North and South America are finally joined for the first time in tens of millions of years. And because of that, there's a whole bunch of animals in the south that move north and a whole bunch of animals in the north that move south. So everything here in blue is a southern South American species that has a North American origin, and everything up here in brown is the reverse case. So a lot of this stuff is extinct. You might not recognize it, but for example, llamas and peccary, tapir and lagomorphs, and all cats, horses, all of those are groups that were not in South America before 3 million years ago. Those are all animals that started out in North America and moved south. This is irrelevant information, but the North American invaders had a much better time moving south. Most of the animals that move south have gone extinct. Most of these things are not around anymore, but armadillos and opossum are actually examples of South American species that moved north and stayed here. And Arizona has always been an important corridor in this migration. We're kind of situated right there at where North America really expands. And you can see this exchange happening in the fossil record. These are all things that I've picked up in southeastern Arizona. On the left here, this is a tooth of a machairodont, which you may know by the name of a saber-toothed cat. So this is that saber tooth right here. And if you're close, you can even see the serrations are still present on the side of that tooth. And that's an example of a North American group that moves south. Cats were from the north, moved south. Jaguars and all those things were not there previously. This is not something that you'd see walking around today. This is called a glyptodont. And they're basically small car-sized relatives of an armadillo. And that is a single hexagonal shell from that big carapace piece. And as a xenarthran, this is an animal that started in South America and moved north. So we have all of these animals all being buried in the same place here in Arizona. So Arizona, the borderlands have always been a place of migration. And migration is going to play a key part in how we deal with the climate crisis, because the reason animals are moving is because the biomes move as well. So this is a tool that you can use. Again, this stuff is listed in the speaker's notes of the slides. And this is a tool where you can put in a place that you live, and it will show you how far north the climate is going to move and how different the climate will be in the year 2080. So in the year 2080, our climate here in Tucson is going to be most similar to sorry, I'm getting tripped up here. So the climate is moving north, and therefore we are going to have the climate of a more southern area like Hermosillo in Mexico. I need to draw an arrow on there for my own use because I'm so stupid. So anyway, yeah. So the biomes move north, and they also move. So they move poleward, I should say. So everything gets warmer around the equator first, and therefore the biomes are going to start moving towards the poles. In addition to that, they're also going to start moving upwards in elevation. So stuff that's used to a particular climate, it's going to shift north, it's going to shift up. And that's what we have to expect. And therefore, it's no coincidence that one of the big political issues of the borderlands are the fact that we are on the border between these two nation states. And our former president made one of his very early memes out of the idea that we were going to build a physical barrier between the United States and Mexico, and that Mexico is going to pay for it and all this shit. And basically, there's a lot of reasons for this, but it's because migration, again, is a natural response to changing climate. And so people have been moving north from Central America for many, many years for a number of reasons. A lot of it is climate. It's getting harder and harder to grow food down in Central America. This is also caused by the United States interfering politically with the governments of North and South America, or Central and South America. And therefore, these people are refugees fleeing climate and political instability and all kinds of really nasty things. And the United States solution to that is just to physically build a barrier to prevent people from coming in, right? Not quite. So even the most, just completely out there Republicans understand that we can't build the wall everywhere. You can't wall up a stream. There are plenty of rivers that go over the border. There are areas that physically we cannot put this infrastructure. So instead, the wall is a strategic system that is being built in selected places. They're not trying to wall off everywhere. They're just trying to wall off safe areas of passage to force people into corridors that are a lot harder to travel through, that are more dangerous. And when you do that, you increase mortality. So more people will die trying to move north because they're funneled through these areas. And it works. You can see in this map created by Humane Borders, there's this dense cluster. Every single one of these points is a human being whose remains were found in the deserts of southern Arizona, migrants trying to make it north. And every single one of these points is a person that has died trying to do this. And you can see that they all get funneled into this particular area because this is a harder area to move through physically. It's a lot hotter. There's fewer areas to get supplies and that kind of thing. So this is an intentional choice that our government is making to wall off areas that are safer to go through to force people into these lethal zones. And I'm personally really frustrated with the Democratic Party, especially for a number of reasons, but especially when it comes to the border wall, border issues, it's kind of played off as a joke, right? So everyone's seen that video of that section of wall that got blown over in Texas, and Democrats played it up to be like, well, the wall's gone. They built a little portion of it and it blew right over, so we don't have to think about that. And this is not true. The wall was, in fact, as far as Arizona goes, it was mostly complete by the time Biden's administration came into power. And although right at the beginning of January, he put a hold on construction of the border wall, it's looking like the feds are actually going to let them continue to build the wall under the Biden administration. So as far as voting for Democrats to protect the environment, they are literally no better than Donald Trump in this particular instance. The removal of the border wall is a really important thing that no one is going to bat for. And so we need to start getting a lot louder about that. And just to, again, demonstrate what we're at risk of losing here. So these are the border counties in Arizona, and everything marked black is a species that has gone completely extinct in this area in the last 250,000 years. And everything marked in red are all the species that we are going to lose in our lifetimes if the border wall is not removed. So you can see just how much is already gone and how much more is at risk of being lost. And down here on this table, you can see, like, again, Nothotheriopsis, no one's seen a ground sloth in our lifetime. So these you don't really think about being gone, but we had two species of elephants, mammoth and mammothus. Mammoths and mastodons used to live here, and they're all gone. Nothotheriopsis used to be a big consumer of desert globe mallow, which is this pretty little orange flower that I find all over the place near my apartment. It's sloth food growing here for a population that doesn't exist. And so bighorn sheep are at risk of extinction. Antilocapra, which are, pronghorn, are at risk of extinction. Panthera, so jaguar, actually live here. Fun fact, this is Panthera onca, but technically there would also have been Panthera atrox, which is the American lion. There's an entirely different species of big cat that we used to have that's now gone. Mexican gray wolves are also at risk because this physical barrier separates this northern population from their counterparts in Mexico. And logically speaking, the more that you subdivide the gene pool and prevent intermixing of those genetics, the more, the less fit that population is going to be. And you get funneled into this thing that's rather dramatically called the extinction vortex, where basically you continue inbreeding the population to the point that you'll never recover enough variety in your gene pool to have a healthy population. So you just go extinct. And that's why these things are physically at risk because of this barrier. It's not that the wall is actually like killing them. It's because they've split this small population into even fewer parts that will all eventually fade away if we don't take action and remove those barriers. Not just the wall that was built in the last year, but all the physical barriers that were put up in 2006 when the original border protection stuff was being put in place. And it's also dangerous to be a borderlands activist. We have two examples here of advocates that have been threatened with legal action. And fortunately, these both have happy endings. So many of you are probably familiar with Dr. Scott Warren, a volunteer for No Mas Muertes, who was arrested in 2018 for providing shelter to two migrants in his home. And this was basically the feds' attempt to put their, to really drop the hammer on people trying to provide shelter. And so Scott got lucky because it was considered his religious freedom. It was considered an act of expression of his religious beliefs to provide shelter for these people. So he was acquitted, thankfully, in 2019. And Amber Ortega, who we're clearly familiar with, was also arrested and also acquitted on that same thing, religious freedom, basically. She's a Tonawatan woman who was praying at Quito Baquito Springs, which is this really small endangered area, the only home to several species of desert animal, mudfish and turtles and stuff like that. And so she was there at that site where border wall construction was taking place, and they're pumping this water. Remember, you have to pump water to mix concrete, and they're not taking that in from a viable aquifer. They're pumping that up from the groundwater. And so people have been noticing that the water levels in Quito Baquito are lowering because they're pumping that water up to build the wall. And so she physically impeded construction while she was there. She was then arrested and thankfully acquitted in 2021. So just putting this out there, if you are a person of faith, you kind of have a little bit of leeway here to do just the tiniest amount of industrial sabotage. Now, the impact of the mining industry on the area that we live is also significant. This is not something, and I work in this area of New Mexico, and I did not know about this until about 6 months ago. So in the late 1970s, there was a uranium mine near a place called Church Rock in New Mexico, the kind of upper northwest portion. And the dam that was holding in all the radioactive waste and stuff burst. And we know from testimony that people working for United Nuclear Corporation knew that it was at risk weeks in advance and didn't do anything. And when this dam burst, it released 1,100 tons of uranium waste and 94 million gallons of radioactive water into the Rio Puerco. And this is a place where this is traditional Navajo land in Etah. And this is where people, this river is where local farmers are watering their sheep, and they have to physically cross it all the time. And there's stories about, shepherds coming in to water their sheep and coming out with chemical burns on their feet. A lot of livestock are slaughtered in the wake of this because they started, cutting them open for food and finding out that the belly fat is like bright yellow as opposed to white, what it's supposed to look like. So this is a major environmental disaster that happened in our area. As a matter of fact, it's the largest single accidental release of radioactivity in US history, bigger than 3 Mile Island was. And despite that, only 1% of that solid radioactive waste has been cleaned up since then. This is 40 years ago, and this has still not been taken care of. And there are hundreds of Superfund sites around the Southwest of this exact thing, uranium mines that have not been cleaned up properly. And in addition to that, Oak Flat in Phoenix is also under threat. So this is a sacred area to the Apache tribe. And there's a number of cultural rights and stuff like that takes place on this land. And everyone's favorite Senator John McCain basically sold out Oak Flat to a mining company in 2014 to be extracted for copper. And the particular method they're trying to do here is basically going to form a sinkhole underneath Oak Flat and swallow it into the earth. So this is an important, really critical conversation that we all have to have as far as how much are we willing to put up with as far as mineral extraction. In building the new green world, we're going to need lots of minerals and rare earth materials, and we're going to get into that in a minute. But the impact, especially on indigenous communities, of this extraction has to be taken account for. We can't be building, a better world on the backs of these other people that have already been crushed by capitalism. In addition to that, obviously, wildfire and drought is a big issue right now. I want to remind everyone of the Camp Fire that happened in California in 2018, where the entire town of Paradise, California was burned to the ground. This is going to be a more common thing to see. It's just entire towns being wiped off the map due to extreme climate events. And I'm going to talk a little bit about municipal ownership of utilities. And this is an important thing to bring up in context of municipal utilities, is that because PG&E, the privatized utility, was not maintaining their own infrastructure, they caused this fire. They are directly responsible for 88 deaths and 150,000 acres of being burned, 85 people killed, because they decided to basically do what capitalists always do and try to put in the minimum amount of money for the maximum amount of output. And in doing so, they got an entire town wiped off the map. I also want to bring up the fact that because Arizona has based so much of its economy on the carceral system and on importing prisoners, and we have laws mandating a certain amount of people in our prisons at all times. And this is an extreme risk. These are people who are part of our community, whether politicians like to think of it or not. Prisoners are part of our community, and they are at extreme risk for climate-related, health episodes. So there is a really cool little tool called Climate and Punishment. This is the full map of all prisons in the United States. And you can go look at each prison and see its evaluation for how much risk the prisoners are at from heat stroke or just general heat injury, from fires, and from flooding. And so all 11 Pima County prisons are rated as extreme heat risk. 2 of them are at moderate to major flood risk, and 6 of our 7 or 6 of the 11 are at severe to extreme fire risk. This is a juvenile detention center just north of town that is estimated to spend 105 days above 90 degrees and is in the 97th percentile of wildfire risk. So this is an area that is almost certain to have to be impacted by increased heat and increased fire regimes. So decarceration is a key part of climate policy. These are members of our community who don't have any way to protect themselves from the impacts of changing climate. And in the context of wildfire and drought, we obviously have to talk about water management. My card's on the table. I don't know a ton about water management, but it's easy enough to look at, like, for example, this is Lake Powell, and you can see how much further down the water levels are compared to where they used to be. We know that water is drying up. This is a desert. There were never supposed to be this many people living here. And it is possible to be much, much smarter about how we manage these resources. And a paper just came out earlier this year that classifies the current drought that we're in as being the worst we've ever experienced as far back as the record goes. So the year 800 AD is the earliest we can begin our climate record in this area. And we do that actually via tree rings. Way down on that way is the tree ring lab, and I took a couple classes there. And they actually show you the slices of tree that are from that year. And you can see the beginning of our climate record. And this year will determine, if we have another severe drought this year, will determine whether this is the #1 longest drought, 23 years. The previous record holder was a 22-year stretch during the 16th century. So that's something to, I guess, look forward to, is finding out how historically bad our drought is. Any questions on that stuff? Yes.
Yeah, again, a comment rather than a question concerning mining.
Okay.
Specifically copper mining.
Yeah.
You brought up Oak Flat, which is great. Okay, a little closer to home
would be Rosemont.
Well, there's Rosemont, but the north side of the Catalinas. Okay, my partner and I do trail work on the Pima Canyon Trail. A guy came along who consults to mining companies to try to get them to comply with environmental regulations, or at least not commit the horror shows they've traditionally committed in the past.
Right.
He says that there is great interest in the old mining claims on the north side of the Catalinas, where copper was mined past along the hill. Anyway, so he's consulting companies who are considering reopening those claims just the other side of the mountain crest. Yeah. Just so people know. Yeah. Because the price of copper is going way up. Yep. It's capitalism in action, right? And one of the reasons, according to this guy, anyway, that copper has been going up, is that the demand for electric cars is contributing. Yep. So I just wanted to bring that little irony to your attention. Yeah. Yeah, and the way that these mining claims work is that they leave a significant amount of material in the ground usually, and they're basically just doing a constant cost analysis. Are we getting more out of the materials by exporting it or by leaving it in the ground? And in this case, yeah, if prices for certain materials like copper continue to rise, we will see these abandoned mines beginning to reoperate. I would argue that we're better off, developing better recycling technologies, so that we don't have to take more copper out of the ground and we can use the stuff that's readily available. But capitalists do not think the same way that I do. And speaking of, when we finally get rid of those bastards, what are we going to replace that society with?
this is a really important thing to keep in mind. We have to be intentional about what kind of society we're building after the climate catastrophe really sets in. And again, I don't want to like concern anyone, but we are facing a period of major change. If there's anything that working in deep time has taught me, it's that nothing is permanent. Everything goes extinct eventually. Humanity will die out at some point. It's just a fact. It doesn't have to die out right now, though. You know, we might be able to buy ourselves some more time. And there's no reason why we can't, you know, take these periods of change and implement revolution in our regimen, right? And we'll get into that in a second, but it's important to address the question, why hasn't capitalism come up with a solution to this? We've known about climate change for well over 100 years. The earliest research on what CO2 in the atmosphere does was put out in the early 1900s. And so if people were really taking this stuff seriously, we could have been well on pace to take care of this. And yet we haven't. All the conversation about climate is, you know, basically fear around the fact that we know things are really bad and yet nothing's happening. And I don't know what I'm supposed to be doing about it, but no one's doing anything. And are we seriously going to sit here and watch this train come and hit us? So capitalism clearly is not offering any solutions here. And that's because the answer to the question, why hasn't capitalism solved the climate crisis, is that it literally can't. Capitalism is predicated on the idea that we measure progress by compounding continual growth. It's not enough that I produce something. I have to produce more than I did last year. And I have to produce more the year after that and the year after that. If I'm not showing growth in that sense, I'm not really on the up and up. And that's just an incompatible idea with the world that we're currently facing, where we have to start thinking about ramping down certain areas of industry, where we can't be burning fossil fuels anymore. That has to go down. Capitalism doesn't have a mechanism for rewarding decrease in consumption, and it never will. So yeah, as an economic philosophy, capitalism is incompatible with ideas of responsible growth, what growth is necessary, and what growth is ecologically justified. It just doesn't have a way to deal with those concepts. There are some things that get thrown out. The deal with electric vehicles, as was just brought up, is that in order to build those batteries, you need to be using a lot of rare earth minerals. Lithium and cadmium are really important, as is copper. And I put the burning Tesla here because I really like making fun of Elon Musk. I think it's important. I'm proud of him for introducing something new to the car market, which is a vehicle that spontaneously combusts. You don't see any other company putting out models like that. So that's really cool. But as far as like, is putting a Tesla in every home going to solve the climate crisis? The answer is no, because we need to have fewer cars on the road in addition to cars, that are electrically powered and not burning gasoline. And yeah, lithium and cadmium in that supply chain have horrible records of human rights abuses. A lot of those minerals are mined by child slaves in Africa. Elon Musk more or less directly admitted to being involved with the coup in Peru or Bolivia because they have a huge lithium supply. And he was just saying, hey, we'll coup whoever we want. We want those materials. We need them to build the green future. This is what you want, right? So again, we have to be really conscious of the fact that we need to improve conditions for everyone. We need to make sure that in building this new future, everyone is getting into a better place, and we're not pushing we're not basically putting other people down and severely impacting them in order to build new conditions for us. And other stuff that gets thrown out there is just downright ridiculous. I could spend hours talking about why this doesn't work, but there are lots of people who think that like big scale terraforming of the planet, basically taking advantage of the natural albedo effect, right? So when a volcano goes off, it releases burning hydrogen sulfides. And that stuff in the atmosphere does deflect sunlight. In our climate record, we have dips in global temperature when there's big volcanic eruptions. They're not permanent, they do go away after a couple of years, but it is noticeable. And so these people want to cool the climate basically by releasing burning hydrogen sulfides into the atmosphere. And again, I could spend all day explaining why that doesn't work, but essentially you need to be expelling energy to get it into the atmosphere in the first place. And the cost of that alone offsets any gains that we're getting by cooling the climate that way. And in addition, if at any point we ever stop doing this, the bounce back from like our nice cool industrial level to like 4 degrees Celsius, that is a worse scenario than just kind of gradually getting there. Because at least at this point, we can adjust for it year for year. The jump would be catastrophic. So no, a lot of the like really cool, oh, we're going to terraform Earth, all of that stuff, it's not going to work. And it's also a misdirection because capitalists, you know, really need to hide the fact that it's the capitalist class that's really responsible for how this is going down. The richest 10% of the global population is responsible for 49% of global carbon emissions. And I'll get into Malthus in a second, but there's been a long-standing political philosophy that it's the poor that are responsible for damaging the environment. They have too many kids, they're irresponsible with their land, they tear it up, they put things that they're not supposed to. And there's just these massive hordes of people that are taking up resources. And if only we educated them or maybe killed them all, we would be fine. And we need to refute those ideas. And this is basically the softest way people try to press that concept is that, you know, it's the global South really that's doing the emissions. And no, it is the richest 10% are responsible for almost half of this. And in addition, the number that I'm sure everyone's heard before, just 100 companies are responsible for 71% of global emissions. It's the capitalists that are responsible for this. They are killing the planet. They want you as a consumer to feel like it's on you to make better purchasing choices and not on them to simply stop doing these destructive processes in the first place. In addition to that, there have been, you know, some campaigns over the last few years to introduce a massive spending bill, basically to convert our infrastructure, convert our economy, and to get ready for this next stage of the climate crisis. But at this stage of the game, the Green New Deal does not exist. And there is no one with any real power in this country who is fighting for this. We obviously have people in Congress and we have people at local levels who really want a Green New Deal. I believe Mayor Ramiro in Tucson has signed a declaration saying we need to do a Green New Deal. But this required a national campaign to get this implemented universally and make sure no one was left behind. And at the moment, this is just not going to happen. Joe Biden is not interested in this. He's really interested in this, putting a burning Tesla in every American's car or in every American's garage, which, as I just went over, is not going to solve anything. In addition, the Paris Climate Accords, while obviously, again, being a big thing that Joe Biden was pushing, this is not a real solution either because the Paris Climate Accords are non-binding. It's not, it's basically a handshake. It's not anything that can be enforced by an international court, as if international courts have ever had any enforceable laws in the first place. But the other thing I want to point out here is that this 1.5 degree target that was set, basically they say we want to cap global warming at 1.5 degrees above the pre-industrial average. There's nothing unique or special about that number. It's just something that they picked. It's not like 1.6 degrees is horrible, 1.4 degrees is safer, 1.5 is like the limit. We're doing damage to the climate if we get to this point. We're almost there already, and we will probably blow past it. It's not like 1.5 is the perfect magic median. This is an arbitrary number. We should be keeping it to the smallest amount of warming we possibly can. And just to put things again into a large scale perspective, if you consider the earliest humans to be like anatomically a modern Homo sapiens and the beginning of capitalism to be sometime in the 18th century, capitalism has only existed for about 0.1% of human history. So it's a really common thing for capitalists to talk to you as if this is the base nature of mankind. This is how it's always been. And in order to do something more ecologically sound, we have to change human nature somehow. Capitalism is not natural. This is a choice that we've made or that was made for us, and we can choose to do something else. And again, from the way I look at things, everything ends at some point. So we know that capitalism is not the final form of human society. There will be something after this. Capitalism will be superseded. And so we get to play a role in what that society looks like. And we better choose carefully. Because we are not the only ones who understand these issues. So the political left is not alone in understanding the challenges of the climate crisis. More and more often now, you see people on the far right will start kind of flirting with ecological concepts, talking about how, yeah, we are going to start running out of water. We are going to start running out of food. And in order to protect ourselves, and by ourselves, they usually mean either the nation or the race. For eco-fascists, those are one and the same. They start pushing, we're the environmental option, but we're doing it for racist reasons. And we need to be really careful to know how to look for those things and separate ourselves from it and refuse it in every possible sense. And this is not new. So there's this bastard Thomas Malthus who is responsible for like ruining the field of ecology when it began. So in this period of enlightenment, a lot of these people who are foundational to these fields of science were not really curious about understanding the world as it is. They were more interested in trying to justify how they live by saying, well, it's like this in nature, so it's perfectly fine that I get to be rich and other people get to be poor. And so his major contribution to this conversation is the Malthusian trap, which is an idea where a population grows exponentially, but a population's resources can only grow geometrically or arithmetically. So at some point, your population is going to vastly outstrip its resources, and then you get massive die-offs. And this has been proven wrong, first of all. So this wasn't true in the beginning, but it was taken as, again, justification for enabling or worsening famines and stuff like that, because, well, they're overpopulating. This is just a natural consequence of them doing that. There's nothing we can do, in context of like the British messing with the Irish food chains and stuff like that and causing famine. And yeah, he's since been proven wrong regardless, because countries that do achieve a decent level of food security, everything's fine compared to the rest of the world, you see their population start to decrease, right? Places like Japan and Europe and here in the United States, people are having fewer and fewer children, and which is the exact opposite of what Malthus proposed, that as food security gets stronger, people are just going to have more and more kids. Turns out people don't actually want to have litters of 6 or 8 kids. They're just doing that because in a different type of society, you need big families in order to take care of things, right? To produce for you. And in societies like ours, you don't need that. And so people naturally have fewer kids. You'd think that that would be a deterrent for Malthusians, but they actually don't care. They think, actually, this is a great reason why we need to keep being racist, because it means that the birth rate of the first world, specifically white people, is decreasing compared to other places. And so we need to really freak out and be protectionist and blood and soil, basically. This is our unity. We need to protect our land for our people. And the only response to that is, first of all, you need to cure yourself of that type of thinking. You weren't expecting the first meme to show up in this presentation 89 slides in, were you? Yeah, so first of all, it's because this is such a prominent idea, you really need to stop and consider when these kind of Malthusian ideas are slipping into your head, and where you start having attitudes about like, oh, these people are just irresponsible. Look at all these hordes of people. Fox News is really good at this. By taking footage of like refugees moving through the Central America and framing it as this like untamed feral horde coming to us. Kill the Malthusian in your head. Anytime you look at photos of climate refugees on boats and stuff moving here, if at any point you start feeling a little freaked out, kill a Malthusian in your head. They have a right to seek better conditions for themselves, just as you do. And in other contexts, the only way to deal with a Nazi, oh, sorry, we're not at that part yet. So this is not theoretical. And unfortunately, the first time that I gave this presentation, the Christchurch massacre in New Zealand had just happened, in which 51 Muslims were killed while praying at a mosque. And explicitly, the Christchurch shooter listed principles of eco-fascism. You can read his manifesto. I wouldn't suggest it, but I have, and you can read through it and see where he's pointing out, like, we need to kill non-white people in our white country, New Zealand, which is not a white country. We need to start killing people that aren't white because they're taking up our resources. And the El Paso shooting in 2019, same thing. These people are specifically citing Malthusian ideas about population and about resources, and it's go time for them. So fascists tend to prefer stochastic terrorism to just kind of generally freaking people out and getting them stressed. But this is explicit, violent terrorist attacks that they have been doing, and I frankly wouldn't expect that to stop anytime soon. And yeah, as a community, we have to recognize that anti-fascism is community defense, and we need to keep an eye out for those attitudes as they emerge and refuse to allow that to have a foothold in our society. Fascists will not pass. This is the only way forward. And additionally, again, we get to choose what the post-capitalist economic order should be, and we have to choose to not try to dominate nature at the same time that we're not trying to dominate each other. So we're all socialists in this room, I think, and therefore we agree on the idea that we don't want to be dominating other groups of people. This is all about economic freedom as well as political freedom. And this new society has to be conscious of the way that it interacts with the ecology. We know a lot more now about nature than we used to, and that knowledge has to be incorporated with how we conduct ourselves. And this is, again, this is not a new thing either. So at the same time that people like Malthus were starting to pollute ecology with other concepts, we have people like Kropotkin, who's a really interesting character. He was a prince in Russia that was in prison for a really long time, went out, wrote some really famous books, one of which is called Mutual Aid, A Factor in Evolution, published in 1902, that argues that the Darwinian concept of evolution that's really commonly spread out, the idea that animals or organisms compete with each other for survival, is actually wrong. Organisms compete against the environment. It's a struggle against environmental conditions. And when you look at the whole of the ecology, you will notice that organisms actually help each other more often than they're directly competing. And that is the argument that he makes. Mutual aid is as much a law of animal life as mutual struggle, but that as a factor of evolution is probably a far more greater importance. And as someone, again, with a degree in ecology and evolutionary biology, this is what I subscribe to more. I see this as being more true than in the reverse. And actually, my criticism of the education that I got is that we were still uncritically citing Malthus as an influence in ecology and just saying the Malthusian trap as part of the teaching process and not critiquing it in any way. Just in case you guys thought I was just blindly repeating, what my teachers told me. We weirdly did the math of the prisoner's dilemma and the mathematics of altruism. You can mathematically prove that communism works in that way. Literally, we did this in class, and we proved that mutual aid is the more successful method, as opposed to just direct competition all the time. But we never did anything with that. That was just the end of the class, right? And so the education that you get the science, but the political implications are never really touched. There's so many other figures that I could put in here, but he's one that I wanted to point out just because he's also a paleontologist. I'm rather fond of Gould. And this quote that he has, "I am somehow less interested in the weight and convolutions of Einstein's brain." That's a reference to the race science ideas about, a person's particular brain mass and shape and stuff tells you about their intelligence. He says, "I don't really care about that. I'm less concerned about that than in the near certainty that people of equal talent have lived and died in cotton fields and sweatshops." The idea that the reason certain groups of people seem to be more successful has more to do with economic conditions and not to do with they've got an extra lump in their brain, unlike the lobe back here, right? And that is correct. He has the correct opinion of how all that stuff works. So the science does back up here that social ecology and ecosocialism is the better way forward. It is scientifically supported. It's, in my opinion, morally supported. So let's get to it. What are the core tenets of ecosocialism? So we have to have democratic governance, if any at all, and worker-owned economies in order to be socialist. But in addition to that, we need to have publicly owned infrastructure and push the idea of civic ecology, that it is part of your responsibility as a citizen to be conscious of your impact on the planet. We are all stewards of the land that we use, and it is our responsibility to respectfully utilize, manage, and restore that land. And I use the word use and not occupy here because, I physically occupy a certain amount of land. I occupy my house. I occupy my parking space. For a brief period of time, I occupy a classroom. But my impact on the land is far more broad than that. I am impacting in small amounts, the Midwest when I eat food that's grown there. I impact Africa when I use minerals that were mined there. So we have to keep in mind that just because I don't physically step foot on those places, I have an impact on that. And I don't have direct control over, the moral extraction of materials from places I'm not physically in, but it's still our responsibility to be good stewards. And the socialism part comes in that basically we can achieve these kinds of things, democratic control, we can achieve civic ecology, a situation where we actually do convert our energy production to renewables, where we are not deforesting, where we are not building suburbs where they don't need to be. The only way we can do that is under a kind of socialist society. We can create necessary conditions for this type of society by pushing for the public ownership of public goods, decentralization of amenities that we can locally produce, and rewilding of every possible square inch. So again, a really common climate change conspiracy line is that this is just the government pushing communism. I want to make this really clear that the government does not think this, I do. Right? Joe Biden is not trying to push for public ownership of amenities so that, or just talking about climate change because he wants to, steal your toothbrush. He doesn't care about any of that. But I do. I am coming for that toothbrush one way or another. And yeah, basically, what we need to do is to start having better, more responsible usage of our homes, of our streets, of our, farms. And if your question is, I don't have direct control over those things, what if you did? That's really where this all comes down. And more importantly, I want to emphasize that we can't wait for the utopian state for this to happen. Even if you're not a socialist, you don't believe in a socialist revolution, we can't wait to elect a more ecologically conscious government, because that, if it will ever happen, is going to take a very long time. And we don't have time to afford here. So the time to act is now. And we have to be, what I'm hoping to show you is that there are a lot of things that we can do as individuals and as a collective community that does not require a utopian state to exist. We'll go over actions you can take today in the next section. I will show you on the large scale what, as a human, as mankind, what do we need to accomplish here? That's in the wrong place. Okay, so apparently I ordered these slightly wrong. So these are things that we've done and can do locally. First of all, I'm really proud of the fact that our water Tucson was successful in its campaign last year. So Tucson DSA was approached by this campaign to implement differential water rates. Basically, the outlying areas around Tucson are able to use Tucson water at the same rate as people who pay Tucson city taxes, but they don't. So they get our water without having to maintain our infrastructure. And so this campaign was run on the idea that we need to implement taxes for those people who use our water but don't pay for our infrastructure. And then we can use that money to do a number of things, one of which was canceling water debt for 100,000 or 10,000 families, expanding low-income assistance program, and investing in climate resiliency. So we have $3.3 million now earmarked at the city level to do climate resiliency. And it was passed on to us by Ed Handel that they're looking for suggestions on what to do. So if you don't mind, here's a couple of things that we could do. As I said, we need to have public ownership of our utilities. TEP is being obstinate in the implementation of solar. It's insane to me that Tucson has some of the lowest solar panel density out of anywhere in Arizona that I've been. I was just near Flagstaff, and they have more solar than we do down here. And TEP is part of that problem. They're not investing in that infrastructure. And I believe that has something to do with the fact that they're owned by a Canadian holding firm, that the people who own our energy are hundreds of miles away in a different country. And so you probably can't buy TEP for $3.3 million. We might have to seize it through eminent domain. Or, for example, support a worker strike at TEP, where workers refuse to continue generating energy until the holding company agrees to sell their share to the city of Tucson. There's different paths we can take to do this, but we need to own our own electric grid. And only when this is under democratic control will we be able to implement stuff like increased solar, more wind, and recycling programs as well. Mesquite is a, I hate this term, superfood, but or super plant, but mesquite is one of our aces in the hole here as far as drawing down carbon. So mesquite grows really, really quickly, and it's a dense hard wood. So those trunks are full of carbon that they're taking from the atmosphere. And so we should be growing mesquite all around Tucson, preferentially. We don't need any more palm trees. We don't need any more pine trees. We need more mesquite here. And A, it draws down carbon. B, it produces food. Those pods can be ground up for flour. And they actually have, compared to like other types of nutrients, this is actually more calories, same amount of protein, more carbs, and then fat, a lot more fiber too. So mesquite flour is actually a really important resource. And we can kind of kill two birds with one stone by sequestering carbon and by producing food. For example, if we're going to be building this Amtrak road trail between Tucson and Phoenix, you need to build sound barriers on either side of that, which you usually do by planting trees. And so if we plant mesquite groves on either side of this track, we can build a giant green belt from Tucson to Phoenix that, if it's managed properly, can be harvested for food. And ideally, if this is all publicly owned, that flour should be donated to food banks. I think the city of Tucson should be, if it doesn't do this already, it's kind of hard to get into the weeds of it. But if we aren't harvesting mesquite pods, grounding for flour, and then donating that flour to food banks, we need to be doing that like now. And there are, yeah, so there's so many other things that I could list here, and I just frankly ran out of time to list. But this is the kind of thing where we need to be meeting more often to talk about solutions to the climate crisis on a local level. So at the end, I'm going to give you ways to get in contact with me. We need to be having these discussions more often. And just, so this is what I thought we were going to do previously. So on the broad scale, here's all the big accomplishments that humanity has to achieve by 2050. Solar, we're going to implement solar farms. That's going to save 36.9 gigatons of CO2 and save us $5 trillion. Wind turbines reduce 84.6 gigatons of carbon. That's 1,000 tons is a gigaton. Save 7.4 trillion. Geothermal energy saves us 16.6, saves about $1 trillion. Rooftop solar. So again, this is decentralizing energy production down to the local level. And so we can produce a certain amount of our energy for our homes on our homes. And that itself will save 24.6 gigatons of CO2, save us $3.46 trillion. Farmland restoration saves 14.08 gigatons, saves about $1 trillion. Reducing food waste, as we were just talking about, that saves 70.53 gigatons of CO2. So compared to like solar, onshore wind, 70.53 gigatons of CO2. So there's a lot of carbon that can be saved here by being smarter about food. And this is another thing that's not commonly talked about, but in places that are less fortunate, they do tend to use kind of worse fuels. They tend to be wood fuels, or they're burning manure, for example, to cook their food. And if we distribute clean cooking stoves, we can save 15.81 gigatons of CO2 and also save, I don't even know how many millions of lives, actually. A lot of people get cancer and other kinds of inhalation issues because they're cooking with dirty burning stoves inside their own homes. So that's a major thing that our country and the rest of the first world need to be donating to other places to make sure that their quality of life is improving alongside ours. Changing the way that we grow food by putting trees in those pastures is a concept or a process called silvopasturing, and that will save 31.19 gigatons, save a little over $500 million. Automating the way that we do our economy will save a certain amount. Protecting forests saves a certain amount. Protecting rainforests saves a whole lot, 61.23 gigatons of CO2. And just putting land stewardship back in the hands of indigenous people just that alone saves 6.19 gigatons of carbon. So more carbon will be reduced from emission by giving land back to indigenous people as compared to just protecting forest in general. Those things are almost the same in our carbon budget. So this is a really important thing to do, and also protects 843.39 gigatons from release. This is what we have left to lose and release into the atmosphere if indigenous land ownership is not a big part of how we move forward. Logically, it just again, if this was a mixed crowd with the college Republicans, I assume I'd be getting a lot of pushback for this. But it just makes a lot of sense that we need to be putting land in the hands of people whose cultural heritage involves responsible management of the land that you're on. Like, that is knowledge that that community has that we do not. It just makes sense. And I don't know why that's such a difficult thing for people to get their heads around. And in addition, as we were talking about, the kind of refutation to the Malthusian thing is that when food security and in particular reproductive rights are put in the hands of women, they have fewer kids. So when women are able to choose when they have children, how many they have, that in and of itself is worth 59.6 gigatons of carbon emissions saved just by not having more children than they want, right? And being able to plan your own families. So again, compare these numbers, you know, just protecting forests, that's important, but it's minuscule compared to just making sure that people have access to contraception. You wouldn't think of that as being an environmental policy, but it is. So all these stats come from a book called Project Drawdown, which is a very well-researched thing. The guy who wrote that book actually came and taught in one of my classes, and it lists all these different solutions we can. It's got 100 of them listed from 1 to 100. The number one thing that we can do to draw down carbon, prevent emissions, is actually improve our refrigeration. So 89.74 gigatons of CO2 can be saved if we improve our refrigeration technology. And I will argue that refrigeration is not a luxury. It's very, very necessary, as is air conditioning, right? These are things that we need in order to protect ourselves, as far as AC, protect ourselves from the changing climate. It's an important thing. We can't get rid of it now. And refrigeration is important for making sure people have access to quality food and medicine. If we didn't have quality refrigeration technology, the rollout of the COVID vaccine wouldn't have happened, because that stuff needs to be kept at below 0 temperatures in order to stay stable. So these are all important things. One thing I want to point out is that this study was released in 2017, and they said that teleconferencing was worth about 2 gigatons of CO2 and saves 1.3 trillion, as far as just not having people flying internationally for conferences. This has started happening as a consequence of the pandemic. So it'll be interesting to see how the implementation of teleconferencing compares to what was predicted. And in addition, just to put this out there, electrifying cars reduces 4 gigatons, but improving mass transit reduces 6.57 and saves almost $2.5 trillion. So again, it's not just changing, you know, swapping out our fleet. We have to make changes to the way that our transportation infrastructure works. Any questions on any of that? Very, very broad, lots of things to look at. Anything we want to go over on that before we get into the last part?
I'm just surprised that the figure for protecting forests is as low as it is
Yeah.
compared to the others.
Yeah.
I wonder if there are differences of opinion on that.
Possibly. And again, there's differences between just like boreal forests and tropical rainforests. The tropics are far more important when it comes to that. Question.
Another thing with the forests is that, like, obviously protecting forests isn't just about like stopping CO2 emissions. It's also about preserving like ecology and things like that.
Right.
So, like, there are other very obvious benefits to protecting forests than just, you know,
Yeah.
CO2.
It you know, calls back to that classic political cartoon that goes, you know, what if the climate change thing is a hoax? What if we accidentally build a better world for no reason? Right? These are all things that we should just be doing anyway. And it's a happy coincidence that these are what we can do to stop or mitigate the apocalypse. And on that note, because again, this is a very heavy topic, and I get a lot of people who talk to me about it who get very emotional and they're very distressed. And I'm generally, if you haven't noticed, I'm not that worried partly because I do kind of have those tools in my toolkit now. I know what I can do to help mitigate this. And I think by sharing that information, I'm basically up here giving you guys my degree as best that I can. I'm hoping that by demystifying how the climate changes and by showing you what we can do on individual, community, local government, national government, I'm hoping by laying those things out, we kind of alleviate some of that anxiety. So this last part is the workshop. Here are things that we can start doing. You can go home and start doing this stuff today. Part of it is just educating yourself on emergency preparedness. We cannot prevent the climate apocalypse from coming. It is here, and we need to be prepared on how to help people who are being affected by it. So just general things to keep in mind about emergency preparedness: have water and food in your home and in your vehicle, just in case. We remember in the beginning of the pandemic, it might be kind of a difficult thing to put yourself back in that mindset, but think about what was happening at the beginning of the pandemic. We were losing access to basic supplies. Food and water were getting harder to get access to. Have that stuff ready to go in your car and in your home. Have batteries, have flashlights, have phone chargers, have first aid kits. This might seem kind of paranoid, but in an event of an emergency, like if we're getting close to, like for example, if the Catalina's catch on fire again and you're in one of those homes that could be evacuated, have your phone charged before you go to bed and not while you're sleeping, right? So that if you need to get up and go, you have a fully charged phone ready to go. Keep your vehicle fueled every time that there's, some kind of major catastrophe, like when all that stuff is going down with the plants in Texas, that impacts the cost of oil. You should fill up your car if you have a gas vehicle as soon as possible, just to be ready to go, right? And if you don't have the vehicle, make evacuation plans, set money aside for rideshare in the event that you need to escape in an emergency. A lot of people that have trouble getting out of impact zones are because they don't have the ability to just get up and go right away. And the longer you wait or the longer you struggle to get out of there, the worse it'll get. In the event of power outages, do not use generators or grills inside. They produce carbon monoxide, and that's really dangerous. Some of these deaths during these climate events are caused by people trying to generate energy indoors and poisoning themselves. If there are down power lines, never go anywhere near them. You will die. Even if there's a person currently being electrocuted right in front of you, don't touch them. Don't go anywhere near it. Basically call 911. There is nothing that you can do. And if power starts going out, talk to people in your community. That's really the first thing that you should do, is get to know your neighbors, get to know what everyone's needs are. If you have a neighbor who needs medicine like insulin that has to be refrigerated, make sure that you're prioritizing keeping their medication properly stored, as opposed to having your gallon of ice cream at just the perfect temperature. And then depending on the season, monitor for hypothermia or heat exhaustion. How do you do those things? I'm going to show you in a minute. So in the event of floods, don't go anywhere near the floods. Do not enter flood water. It is not water. It's mostly sewage, actually. So you don't want to go anywhere near it. A storm surge of 6 feet is a lot taller than you think it is. And it only takes, 6 inches of water to flip a car or something like that, or to move it. This is kind of common knowledge for where we are. When we have monsoons, you don't enter floods because you will get flipped. But just in general, don't enter flood water, stay away from it. In a heat wave, you need to stay in the shade. This does not necessarily mean indoors. During heat waves, there's extra strain on the electric grid as people are cranking their ACs, turning on fans and stuff. So keep in mind that a power outage is more likely during a heat wave. So go back to the slides on preparedness for power outages on that. And monitor hydration at all times. Signs that you're dehydrated include thirst, obviously, headache, nausea, delayed capillary refill. I have that on there twice. I'll show you how to basically, if you want to check your own capillary refill, you take the back of your hand and you can either pinch the skin on here or you can press down on the nail bed. This is a demonstration we're all going to do. And if the color doesn't return to your skin within a couple of seconds, you're dehydrated. So that's an easy way that your body can tell you that you don't have enough fluid in you, is by poor capillary refill. Dark colored urine. I don't know why it's like, generally on the internet, I see people act like any colored urine means you're dehydrated. It's not. Your pee should be yellow. I don't know, it's weird that I have to specify this, but you should not be pissing clear pretty much ever, because that's a sign that you're overhydrated. Dark colored is bad. Light colored, you need to stop drinking. It's that nice healthy medium that you're looking for. Heat exhaustion is going to come in with flu-like symptoms, your headache, dizzy, nauseous, your body's going to start aching. You're going to have pale and clammy skin. Sometimes you get sunburns, but not always. Again, if you're in the shade or like indoors and it's still really hot inside, you can get heat stroke and heat exhaustion and not be in direct sun exposure. Rapid heart rate, shortness of breath. If you don't treat heat exhaustion, it can turn into heat stroke. And heat stroke is where that pale, clammy skin is going to start becoming, that's hypothermia. Sorry, I could have ordered these a little bit better, but basically heat exhaustion, heat stroke, you will start having dry, hot skin. So that pale, clammy skin becomes dry, and that's how you know that you're really in trouble here. Altered mental states, sunburns, again, though not always, vomiting is an important thing. And if you don't treat heat stroke, it can turn into death. So this is a really important thing to keep an eye on. For hypothermia, if it's a little bit too cold, basically you become hypothermic if you have a 2-degree drop in your internal body temperature. It doesn't have to be freezing outside for this to happen. Mild hypothermia, you start shivering, you have cool or cold skin. But when you get into advanced hypothermia, your body can't shake anymore. You've depleted all of your energy and you can't warm yourself up that way. Your muscles are going to get rigid, heart rate starts slowing, and you'll start to become unresponsive. You treat hypothermia by stopping the heat loss at any means necessary. You're going to seek shelter. If your clothes are wet, take them off. You insulate with anything that you have. Maintain a horizontal position during recovery. If the person is responsive, you can give them sugary drinks, not alcohol, sugary drinks. And if the condition does not change or worsen, you seek medical attention. Again, do not give alcohol to people. The warming effect that you feel is superficial. You're not actually warming up. Don't rub extremities because you can damage frozen tissue. Don't put them in a hot shower. You're going to hurt them. And don't perform CPR if the chest is stiff. Again, when flesh is frozen, it can be recovered if it defrosts. It can't be recovered if you break it, right? This is not a huge deal where we are. Other places you need to be really careful about this stuff. You treat heat exhaustion by moving to a cooler area. This can be under a fan. This can be outside in a shaded area. Remove any excess clothing. Drink cool fluids, not cold. Don't chug cold water. Cool fluids at a reasonable pace and monitor symptoms for improvement. Again, heat stroke is really, really bad. First thing, if you have heat stroke and you can seek medical attention, just do that. Move to a cooler area and cool off by any means. Mist with water, apply cool cloths, packing cold packs on areas where you have major veins. So besides the neck, under the armpits, between your legs, you can submerge them in cool water if you have that ability, and then monitor for improvement. Smoke is a really big issue in this area, as wildfires are a big problem, especially last year, if you guys remember. The year before that, we had that fire really close by. And there are a couple of things that you can do to help mitigate smoke in the air. And one of those is by building your own filtration unit. So one of them just involves taking one MERV 12 filter and putting it on the front of a box fan and turning it on. And that will filter out, as long as you have the right rated filters. And it usually says on the front, it'll show you what your filter can filter out. If you have the right rated filter, it will be able to filter those things just by attaching it to a box fan. So you can do that way, or you can do, or sorry. So if you have someone who has like respiratory issues, and there's only a small area that you're able to get clear, dedicate a room for that person to be in. That's the clear room. Make sure that all the windows are closed, doors are closed, you don't have air coming in or out, and just set the unit in there. Make sure that the unit isn't overheating, because that box fan is basically drawing air through the filter and it's putting stress on the motor. So if you do that too much, or you do that for too long, you can burn it out, you can cause fire. So monitor the unit, don't ever leave it unattended. And if you need something a little bit fancier, you can actually take 4 of those as I've done over here, you can take 4 of those filters and then duct tape it to a fan that way to form a cube. And this is able to, and these are all instructions for how to do that. Again, you take a 20 by 20 section of cardboard, you've got your filters, you've got your fan. You have to make sure that those arrows are facing inwards. Because when this thing turns on, it's drawing air through these filters and then blowing out the top here. So all the particles in here are being pushed through the filter, and this stuff is rated for both smoke and viruses. So this works in a pandemic situation as well. Same kind of particle size will filter out ash and viruses. So basically, again, this is drawing air in through here and then out the top. So you need to make sure that those filters, their arrows are facing the interior. And you guys can feel free to mess around with this at your leisure when I'm done. Yeah, so you tape these things together, put the fan on top, and then put it in a room. And then you have emergency smoke filtration. This unit was $80 to put together. If you don't have those kinds of resources, just getting in a car should be good enough. But, you know, if we have a really bad fire season, you have someone who's, you know, home AC isn't that good, or they have asthma or stuff like that, building one of these units and having it handy in those situations, I think that's a really important thing I think that's a really important thing to do. And I think it's a project that we can take on if we get, you know, resources to put those together, make these kits for people in low income situations who don't have a really good air filtration. Composting is a really important thing that we all need to be doing. Essentially, it's the same thing where even if you don't have recycling, you know, you still need to be separating the recycling. You're throwing it in the wrong trash can, basically. And it's the same thing with organic material. This is all stuff that needs to be recycled, and being put in a landfill is not going to contribute to that recycling. So why do you need to compost? First of all, soil is an important resource that is disappearing. I didn't put the study in here because I thought it might cause too much panic, but there are scientists who say that we're going to run out of available topsoil in like 40 years. And so we're throwing away all the resources that we can use to build soil. So something, I think an important component of civic ecology is learning how to build soil in our own homes and in our own situations. In addition to that, if you throw out these materials improperly, that stuff releases methane in landfills. Methane, again, is many times more potent as a greenhouse gas than carbon dioxide is. And there was some stat in here that I went over like an hour ago that went over just how much, I think it was 40% of our total methane emissions come from food waste. And yeah, globally, 67 million metric tons are released from landfills. There we go. The stat was right underneath it. 20% of total CH4 emissions come from basically us not recycling our own nutrients properly. What can be composted? More than you might think. So there are 2 major categories, your carbon heavy brown matter and your nitrogen heavy green matter. Everything has carbon and nitrogen in it. It's just the ratio of those things. So your nitrogen heavy is going to be vegetable scraps, coffee grounds, that kind of thing. Carbon heavy is going to be dry material. So I prefer dry and wet. Some people say green and brown, some people say carbon and nitrogen. These are all the same concept essentially. So your green compostable matter includes fruit and vegetable scraps. Avoid citrus rinds. I'm going to look up ways to decompose citrus because that's a thing that we have a lot of here. Coffee grounds and loose leaf tea, those are all really good. Fresh lawn trimmings, leaves and grass, weeds and garden thinnings, and then herbivore manure if you're doing a little bit of home ag. If you have birds that are producing manure, cows, goats, horses, if it's an herbivore, you can compost that manure. Brown compostable material includes your newspapers, magazines, letters, shredded cardboard, grain-based kitchen scraps, stale bread. You can throw out the end pieces into your compost and not feel bad about not eating it. Eggshells are good. It's better if you crush and wash them beforehand. Straw and hay, and then wood ash. Those are all good things to put in there. Non-compostable, so anything that has protein, so meat, cheese, fats, grease, none of that you can compost. Bones I have an asterisk by because you can technically burn them and down into like just the phosphorus and then compost that. But don't throw chicken bones into your compost because they won't break down. I wouldn't have a job if fossils didn't exist, right? You can throw a bone into the ground and it will stick around for a really long time. Any cardboard that has way too much like wax, plastics, and heavy inks. So you need to sort your cardboard-based stuff on a case-by-case basis. Anything treated with pesticides, your plastics and steels, all this stuff needs to be recycled the traditional way, and then textiles. Biodegradable does not mean compostable. That's an important thing to keep in mind. And your ratio should be about 30 times your carbon sources to your nitrogen sources. So you need 30 times this stuff to this stuff. And your pile needs to be kept moist. So you need to be watering it kind of like you would water a plant. And you need to be turning the pile frequently in order to get oxygen into the pile. So basically there are microorganisms that live in there that need water and they need oxygen in order to break that stuff down. And you need to keep your fresh scraps below the surface. So if you have all your fresh scraps out on top, you're going to start having a smell problem, right? That's like the first thing people ask me. I've hit up a couple of different friend groups now to put compost in their backyard. And the first question they all ask is this going to make a mess? Is this going to smell bad? Is this going to get me kicked out of my lease, whatever? If you're properly doing it, there will not be a smell because you're going to have a higher ratio of that dry stuff to the wet stuff, and you're going to bury the wet stuff in the pile. And there's really two ways that you can compost. So cold composting is where you have worms and other kind of macro detritivores that you can see. Those are breaking down food waste. And the key component here is that you're not heating up that pile. In a thermophilic bacteria-driven hot composting pile, it's the traditional just pile of stuff on the ground. It's actually bacteria that produce and seek heat that are doing that decomposition. So you want on the inside for it to reach between 135 and 160 degrees Fahrenheit on the inside of that pile. And if you keep it big enough, your pile should be between 3 and 4 feet long, tall at a minimum. If you have a pile that high, it will naturally accumulate and store that heat. And if you're keeping it wet, that'll hold in the heat as well. These are all things that are good to use. Laser thermometers help you monitor the temperature of your pile. Work gloves and medical masks keep your hands safe. Paper shredders and box cutters are good for breaking down that material. If you've got like cardboard boxes, you order regularly from Amazon, that kind of thing. Easiest method is just pile stuff on the ground. If you have pets or wildlife might get into it, consider building kind of a cage for it. And yeah, you need to keep it hot. The ideal is around 150 degrees Fahrenheit, prevents things from laying eggs. So you take your green matter and then you bury it, and you make sure that's watered regularly, and the stuff turns into soil. So this is the first pile that I built a couple of months ago, and it's actually producing real soil already. You break into it and you can smell, it smells like a bag that you get from Lowe's. And then when you're done with it, you can basically sift it out and then take the smaller particles, the finished particles to use in your gardens. Or you can donate it if you want, but I think the more logical thing to do is to utilize the soil that you build. And yeah, you need to be minimum of 3 feet, above 4 feet is tall, above 4 feet tall is best. If your piles are too cold, it means they're too small probably. If they're too hot, you have too much green matter and it probably also smells really bad. You can build worm bins by putting buckets inside of each other. I'm going to go real fast through this. But basically your worm bins, you can just do with a pair of buckets. You put your worms in the inside top bucket, and then you have the other stuff down there below. And this stuff, which is basically hyper concentrated nutrients, will naturally sink down through that bottom bucket. So you need that there as a retainer. And this stuff is also important fertilizer. You can get worms at inch by inch is the only place I've been able to find them in town. It's a little bit costly to get them, but again, they're the only people here. So if you give them money, helps them build capacity for this necessary work. I was telling you guys earlier about azolla and duckweed, which is stuff that should be grown on a massive industrial scale in order to draw down carbon. I experimented with growing it again in a backyard, and you can see that, yeah, in about a month, it increases its mass visibly, and that stuff is great fodder for your compost pile. So you can just scoop that up and throw that on there. You can also use those for bird feed. So I have a friend of mine who's going to experiment rearing quail, and we're going to grow basically all their food in these ponds like that. So we'll let you know how that works out. And you can get those things at this place on Rough Roth, $8 for 1 cup. That's really all you need. for putting together your gardens, once you have soil that you're building, evaluate what you've already got, what you're allowed to modify, and where the sun is going to be. These are, again, a couple of places that we've been putting up gardens. You need to be mindful of where the sun is. And this is mine that I put together. I wasn't originally going to do anything near this fancy, but I put together a kind of emergency shade structure, and my landlords told me to take it down. So, I made this really pretty little garden, and I'm sitting up there in the beanbag couch, and I'm just pissed. So I'm like, I didn't want to put in anywhere near this amount of effort or money, but they made me do it. So there you go. It's real pretty. And I'm really mad about it. And then here's all the other things that I'm going to get around to. I need to grow basically on this front side shade plants in order to prevent that late afternoon sun exposure from just cooking my apartment, which was the idea of putting up the regular shade that the landlords objected to. So we're going to do that. I'm going to experiment with rooting hormone because I'm propagating all of our vines, water reclamation, bird boxes, doing the quail, more about water and soil and milkweed and stuff. So these are all things that, again, I want us to have conversations about. I want us to meet to discuss the projects that we're undertaking. So you all have my email. Please keep in touch and let me know if you do decide to do any of these things. Let me know how it's going so we can kind of collect that information. Any questions on that? Yes.
You say do it yourself, DIY,
Mhm.
rooting hormone. What does that actually mean?
So that would mean instead of buying like a chemical
Rutone or hormone.
would be, I've seen recipes basically for other, like some of it's like honey. You make a dilution of honey and water, and that's supposed to be a natural rooting hormone. So there's a couple of different recipes I'm going to mess around with and see what works.
Okay.
Cool. Anything else?
You know about EM, essential microorganisms, the EM? That was all the rage, I don't know, 5-10 years ago. I
Mhm.
tried it. And so you get a concentration of rather expensive $1 an ounce back then. A solution that has the microbes that are good.
Mhm.
You dilute them with molasses to feed them. And they can-
I actually, yeah, I've heard about that. Yeah. Yeah.
That has worked pretty well with me, but I can't seem to maintain a
Cool.
supply in the fridge.
Excellent. Cool. Well, yeah, in that case, I hope everyone is feeling that they've got, again, resources. This PowerPoint is available to you with all those instructions. So if you're looking into undertake any of these projects just to experiment, please use that information and let me know how it goes. And that, yeah, if you want to get in touch with us, here's places to find us on the internet. You've already got our email. So that is that.